Find the exact values of x and y in the diagram. Well, we see that the 45-degree angle here in the diagram and the 90-degree angle here in the diagram leave us with only one option for this angle. That's also going to have to be 45 degrees. That's because the sum of the three angles in the triangle should add to 180, and 90 plus 45 plus 45 gives us 180. From there, we can use the fact that we have an isosceles triangle with the base angles congruent and therefore the two legs congruent to conclude that y is equal to 7 as well. Given that y equals 7, we can use the Pythagorean theorem, which states that the sum of the legs squares is equal to the hypotenuse square, which means that 7 squared plus y squared will equal x squared. That again is by the Pythagorean formula, or the Pythagorean theorem, which of course is only true for right triangles, which we have here. Substituting our known value for y gives us 7 squared plus 7 squared equals x squared. And that means that we have 2 times 7 squared equal to x squared. And if we take the square root of both sides, we see that we have the square root of 2 times the square root of 7 squared is equal to the value of x. I have not used plus or minus values here because everything should be positive since we're dealing with distances, so I don't have plus or minus square roots, I just have positive or principal square roots. And from this we can see that the square root of 7 squared is just 7, and my answer in exact form is 7 times the square root of 2, and that equals the distance x for the hypotenuse of that right triangle. Y equals equal to 7 as we noted before, and so there is the answer to the problem.